Hey, buddy. So, have you ever dived into palindrome checking before? I've got the scoop on how to whip up a Python function to determine whether a given string is a palindrome or not. Now hold on tight, because we're about to take a detailed ride through Python's implementation and optimization tactics. First off, why palindromes, you ask? Palindromes are more than just quirky words. They are cool puzzles that can teach you a lot about string manipulation and algorithm efficiency in any programming language, and who doesn't love a brain teaser now and then? So, saddle up, grab a cup of coffee, and let me lead you through the Pythonic path of palindrome verification. At a basic level, a palindrome is a string that is equal to its reverse. That's straightforward enough. For instance, race car is a palindrome, while happy, unfortunately, isn't. The first step in understanding how to code a solution lies in recognizing symmetry. Symmetry here can be understood as the string equaling its inverse. This insight leads to a simple Python solution straight out of the gate. Check this out. Python definite is_palindrome. Return s is equal to s wasn't that easy. But wait a second, I hear you ask, is that it? Well, not exactly. When it comes to code, beauty isn't just in the eye of the beholder. Efficiency matters, too, and in Python, that's a crucial factor. Now, this simple slice is Python's elegant way of reversing the string, but it's not particularly efficient for longer strings due to the O-time complexity. To optimize, we want to avoid unnecessary work. Python definite is_palindrome, s is equal to dot join for c in s if c.is alnum, start is equal to 0 end is equal to lay, 1 while end start, if s is equal to s, return false start plus is equal to 1 end is equal to 1 return true. Neat, right? Now consider the time complexity. We are looking at O, which is a drastic improvement over the earlier approach. That's better, but let's not rest on our laurels yet. There's always more to explore. Consider scenarios handling large strings or strings with different cases or special characters. Our current function holds up pretty well, but let's make it better. To handle larger scales, consider using built-in Python libraries that can speed up our string checking without additional memory allocation, like the time module to estimate how long our function takes to run. Python import time start underscore time is equal to time race is equal to is_palindrome hash. Consider such string cases end underscore time is equal to time print. It's fun, educational, and incredibly satisfying trying to optimize for performance while ensuring correctness and readability. There's a fine balance to strike, one that makes coding skills not just about writing the right code but doing so in the right way. It's this blend of art, science, and creativity that makes coding and learning new languages and paradigms so fun. Now, I know you are eager to keep up with the tech world. So, remember to explore, experiment, and enjoy. Python is a language with endless depths to explore, especially with palindrome functions and their diverse implementations and applications. And speaking of expanding horizons, I've got this fantastic resource, Neeraj's TechLab. It's a tech news blog packed with tips, tricks, and the latest advancements in technology. Do check it out, not only for current tech news, but also to fuel your passion for programming. Subscribe there, enjoy the content, and who knows, you might find more palindrome-based quizzes there to tickle your coding brain. Visit neeraj.qzz.io and subscribe to TechLab. Keep learning, keep growing. Much harder task, topic, check palindrome, code in Python in detail for IT fresher details, PRL, line height, 1.5, orphans, 2, widows, 2 text align, left, doctype HTML PPRL, line height, 1.5, orphans, 2 widows, 2 text align, left, HTML lang is equal to NPPRL, line height, 1.5, orphans, 2 widows, 2 height, 13 pt, text align, left, PPRL, line height, 1.5, orphans, 2 widows, 2 text align, left, PPRL, line height, 1.5, orphans, 2 id is equal to head. Title crafting elegant Python code. The journey to mastering palindrome checking. Title PPRL, line height, 1.5, orphans, 2 text align, left, PPRL, line height, 1.5, widows, 2 id is equal to body PPRL, line height, 1.5, orphans, 2 text align, left, PPRL, line height, 1.5, orphans, 2 text align, left, body PPRL, line height, 1.5, orphans, 2 text align, left, h to welcome to py time, h to PPRL, line height, 1.5, orphans, 2 text align, left, PPRL, line height, 1.5, orphans, 2 text align, left, p strong introduction, strong PPRL, line height, 1.5, orphans, 2 height, 13 pt, id is equal to para 1. Once upon a time, in a not-so-distant land, lived an old-school teacher named Mr. Chaudhary, who, in a tech hub like Bangalore, stood out with his traditional teaching style. But that didn't deter him from embracing modern technology in the classroom. In a world where technology is reshaping our lives, programming education became crucial, and I believed Python is the pathway for beginners. These were his first words that echoed through the classroom every Monday morning. One day, as his class of eager freshers buzzed around, it was Python palindrome time. In the Python programming universe, they were embarking on a quest to decipher what defines a palindrome. But the journey was more than just decoding strings. It was about understanding algorithms, exploring Python's flexible approach, handling complexities, and optimizing to become efficient coders. Python definite check underscore palindrome, clean underscore s is equal to dot join for c in sfc dot is alnum, left, right is equal to 0, lay, 1 while left, right, if clean underscore s is equal to clean underscore s, return false, left plus is equal to 1, right is equal to 1, return true. The classroom buzzed with anticipation, understanding, and curiosity as they got hands-on practicing with a variety of strings, seeing the code come alive, and learning through an enriching coding journey. Mr. Chaudhary took them on an adventure towards the realms of time and space complexity, explaining why time complexity isn't the only factor that matters in coding. As the bell rang, marking the end of the class, he ended with a reflection. The real purpose of coding language learning is to appreciate what it takes to solve problems and how algorithms are like magical recipes where the language is Python in our case. And he left them with a note to explore further into the Python ecosystem. Visit Neeraj's TechLab. It's more than a resource. It's a treasury troving tech knowledge. Subscribe and stay in the know to keep pushing your boundaries in Python and beyond. Remember, in a world where technology is reshaping our lives, programming education became crucial, and I believed Python is the pathway for beginners. Your follow-up questions to the much harder task should touch upon various aspects of using a Python implementation for palindrome checking. They should probe how the narrative could be impacted by different conditions, such as string lengths, the use of special characters, and different Python versions. Furthermore, ask about the implications of performance considerations for large datasets and how to keep up with Python best practices. Your questions must align with the constraints and expectations set in a Python coding classroom, such as no unnecessary repetition, a conversational storytelling style, and the integration of these elements into a Python learning experience. The questions should reflect advanced understanding of the language, its nuances, and its applications in real-world scenarios. 1. How would Mr. Chaudhary's tutorial change if the students had a mix of beginners and intermediate Python programmers? How could the narrative accommodate different skill levels without watering down the content for beginners while keeping the advanced learners fully engaged? 2. Given that the classroom has access to Python 2.7 and Python 3.x, how could Mr. Chaudhary integrate both versions into his lesson to provide a comprehensive understanding of how Python has evolved to handle strings and algorithms more efficiently? What are the key differences that he should focus on during this historical coding journey? 3. Suppose that instead of working in a traditional classroom, they had access to a large open-source code repository to practice their palindrome checking algorithm. How could this real-world coding scenario enhance their learning experience? Could exploring and understanding existing code have additional benefits, and how would Mr. Chaudhary guide students through this exploration?